Hello everyone, welcome to my YouTube channel Chemistry Lover. So today in this video I have shown you another rearrangement which is known as Beckman rearrangement. So first of all, this is basically a C2N rearrangement you can see here, from which we can obtain N substituted amide from ketoxime and aldoxime respectively. So what is ketoxime and aldoxime? Let's see. You can see that I have written an aldehyde which is treated with hydroxylamine, and here we need to maintain the pH should be optimum but slightly acidic. Here I have written, and from this reaction we can obtain aldoxime and its structure. Now the aldoxime has two different diastereomeric conformer, which is anti and another is syn. Anti and syn are naming due to the orientation of OH with respect to hydrogen, because OH is located with respect to anti position, and here you can see OH is located with respect to hydrogen at same side, hence it is syn and it is anti. Now since these are two diastereomeric mixture, hence we can easily separate them for their different physical and chemical characteristics. Now we can easily differentiate both of them, and we can add acidic anhydride on both of them, due to which this OH group converted into OCOCH3, which is a classical good living group, you should know. Acetyl group, right? This is acetyl group OCOCH3. Here also the OH converted into acetyl group OCOCH3. Now these two product further converted into alkyl cyanide via elimination reaction, but the other does not. Here you can see this is alkyl cyanide because we have added base on both of them, hence one of them get converted into alkyl cyanide via elimination reaction, or commonly known as E2 reaction, because on the other hand another converted into parent aldoxime molecule. Because here, since this is an anti-conformer, I have written the first page, this is anti-conformer, and you can see this is converted into acetyl group, thus it can be able to perform elimination reaction easily, because the leaving group and the hydrogen located at anti position with respect to each other. Hence this molecule are undergoing elimination reaction to form alkyl cyanide, but it does not. Here these two eliminating group present at the syn position, hence it cannot convert it into alkyl cyanide, rather it converted into its parent aldoxime. Now the alkyl cyanide further gets hydrolysis in alkaline medium in presence of H2O2 and converted into amide. I have also write down its mechanism, because in alkaline medium hydrogen peroxide form OOH minus hydroperoxide ion. This species is known as hydroperoxide ion. Okay, and the negative charge of oxygen donates to the sp hybridized carbon, because it is very electronically deficient. Hence this negative charge of over the oxygen atom donates to the alkyl cyanide and the central carbon and gives this type of adduct. Further, the OH single bond breaks, NH bond formation take place, another carbon oxygen double bond formation take place, and the peroxo bond will break and form this type of amide. So this amide again converted into alkylamine via Hofmann-Bromamide degradation reaction. Similar case we have observed for symmetrical ketone. I have write down the symmetrical because these two alkyl group become same, whether it is to methyl or to phenyl, anything, but these two are should be same. Hence I have considered symmetrical ketone. Like the previous case also, symmetrical ketoxime formed, and it has two diastereomeric conformers syn and anti, which can be easily separated from them for their different physical and chemical properties, right? Now we have added PCl5 because phosphorus can undergo exhibit double bond with the small oxygen atom, and this bond is very much stronger in this case. Hence PCl5, by adding PCl5 the oxygen easily coordinate with the larger phosphorus center, and form this type of adduct. Here again, phosphorus oxygen double bond being much more stable, this single bond between nitrogen and oxygen readily broken, and the phosphorus oxygen double bond take place. On the other hand, the chlorine removed from the system as a leaving group. Due to this, the positive charge might be take place on the nitrogen center, which is not stable at all. Hence, the alkyl group shifting take place from carbon to nitrogen. The R shifted from carbon, which is a migrating origin, and nitrogen become the migrating terminus, and the R which is going to be migrated is the migrating group. So migrating group gets separated from migrating origin, that is carbon center, and gets connected with the nitrogen, which is migrating terminus, and from this type of adduct. Now, as a result, positive charge take place on the carbon center, which is fulfilled by the lone pair of nitrogen and from this type of species, and at last the water nucleophilic attack take place on the carbon center, and we can get this type of N substituted amide. Now there is a question maybe arises in your mind that whether this Beckman rearrangement does take place via syn or anti arrangement. So this is a good question which arises in your mind, that whether this migration I have written, now it can be seen also because these two are being same, so this R also becomes migrated via similar fashion, hence also we can obtain similar product. So you can ask me that whether this arrangement being is anti or syn category. Now for this we need to show you an evidence for this. This is the evidence for anti-migration of Beckman rearrangement. Ultimately, Beckman rearrangement is an example of anti-migration, not syn. And you can see clearly this is an unsymmetrical ketone because these two are different in nature. And by treating hydroxylamine, this is formed unsymmetrical ketoxime which exists in its two diastereomeric mixture. And by aqueous alkali, this one can undergo ANS reaction, aromatic nucleophilic substitution, because here chlorine being a good leaving group easily separated from the system, and oxygen can play the role of inbuilt potential nucleophile. Hence in alkaline medium, oxygen easily play the role of nucleophile and attack on the carbon containing chlorine bond. Thus the chlorine removed from the system and gets back and form this 5-membered ring. On the other hand, this cannot undergo any reaction because here the OH group present with respect to anti position on the carbon chlorine bond. Hence this nucleophilic attack of oxygen does not take place. Thus this molecule on further undergo similar C2N rearrangement in presence of PCl5, which I have shown you on the previous page, and form this type of amide. And it is an example of anti-migration because this bond entirely shifted and connected with the nitrogen by separated from the carbon center. Hence it is an anti-migration rearrangement. So up to this, if you have any doubt regarding this topic, then please ask me through the comment section. And if you like this video, then don't forget to hit the bell icon. Thank you.